Okay, I'm starting the review for the final exam, and I'm working with the practice final. Hopefully everybody has a copy of that. I emailed it to you, and the answers. Okay, so we're going to start with number 1. And number 1 asks you to find critical values. And so here we go. Number 1, part A. Find z sub alpha over 2 for 94%. Okay, there is a cheat sheet in the bottom right-hand corner of the positive z table that gives you critical values for 90, 95, and 99%. And you will be able to use that except on this one first problem. This one has to be done what I call the long way. So we're going to start by saying 94% is equal to 0.94. And then alpha is the number that you need to get to $1. So that would be 0.06. And then you have to take that number and divide it by 2, which is going to give you 0.03. And then you need to put that number in the right tail of the standard normal distribution. So what that means is that I'm going to draw a bell curve, and I'm going to put 0.03 in the right tail. This is z sub 0.03. That's the line that separates an area of 0.03 in the right tail. However, the z table is always concerned with the area to the left. So again, going back to the idea of $1, if you have 3 cents out there, then that means the left of that line is going to be 0.97. So we're going to work with 0.97. Do not go back and use 0.94. 0.94 is gone. 94 became 6, which became 3, which then became 97. So I'm going to take 0.97, and I'm going to add 2 zeros to it. This is like the last problem on the midterm. And so now we have to go to the z table and find the value closest to 0.9700. And my suggestion there is that you just pick a column, go down that column, and when you get close to 9,700, then start going right and left. Otherwise, it drives you crazy. Well, it turns out here the value closest to 9,700 is 96.99. It doesn't matter whether it's above or below. You just have to pick the closest one. And then if you keep your finger on the 96.99 and look all the way to the left and look up, you will see that to the left it says 1.8, and up above it says 0.08, and then you add those together and get 1.88. So that is the value for z sub 0.03. I don't care if you label it z sub 0.03 as long as I see the 1.88. Okay, let's go on to number 2, or part B rather. Part B asks you to find a critical value using the t table, and it says find, which really doesn't say that's up above, but I recopy it, find t sub alpha over 2 for 98% and a sample size of 8. Sample size is another way to say n. So basically what they're telling you here is that n is 8. Okay, so we start the same way. We start with the 98%. This is a different table, though. This is the t table, so it's not the same. 98% is equal to 0.98. Alpha is how much you need to get to $1, which is 0.02. And then you divide 0.02 in half, and you get 0.01. The other thing that we need when we use the t-table is degrees of freedom. And the formula for degrees of freedom is n minus 1. And you need to memorize that. Okay, n here is 8. So it's 8 minus 1, which is 7. So our degrees of freedom are 7. And so the notation that I use is t sub 0.01, that's the column on the table, comma 7, and that is the row. So you go to the t table, and now be very careful on the t table because we always use just the area in one tail. Okay, so going to the t table and looking up t sub 0.01 comma 7, and again remember use area in one tail. Never look at the area in two tail. Just use area in one tail. And so it is 2.998. Okay. Okay, now we're going to do 1C. And number 1, part C, asks for you to find chi-squared sub L and chi-squared sub R for 95%, and the sample size, which we said is n, is 30. Good. Okay. The chi-squared table comes with a cheat sheet. I did email that to everyone, and you will get a copy of that to use during the final exam. And so let's draw a picture of chi-squared. Chi-squared is not like the z or the t. It's restricted to the first quadrant, so everything is positive, and it is skewed. It is not symmetric. And if you're looking at the chi-squared handout, the one at the bottom, which they call two tails, is the one that we want here. So this is chi-squared sub L, which stands for the left, and chi-squared sub R, which stands for the right. Oh, excuse me. Okay, sorry about that. I got a phone call. Okay, so what the cheat sheet tells you is for the right side, you should use alpha divided by 2, and for the left side, you should use 1 minus alpha divided by 2. So we're going to start where we started with the other ones, which is the 95%, which is equal to 0.95, and then alpha, again, is how much you need to get to $1, so that would be 0.05. And then you divide that in half, and you get 0.025. So that's what we'll use over here for the right side, 0.25. And then for the left side, we're going to use 1 minus 0.025, which is 0.975. And use your calculator during the final. Some students do subtraction in their head with decimals and they get it wrong. So just use your calculator. Okay, and then we also need degrees of freedom. I'm going to organize this. It'll fit in there. Okay, degrees of freedom, again, the formula is n minus 1, and this time it's 30 minus 1, so degrees of freedom is 29. Okay, so for the left side, I do the left side first. Oh, I didn't put over here. We can put this one is 0.975 for the left side. So it's sub 0.975 comma 19. So you go to the chi-squared table, sub point, not 19, 29, excuse me. Oops, I've got to use this eraser. It's 29. So 97529 is 16.047. And then for the right side, it's chi-squared sub 0.025, comma 29. 025 is the column, 29 is the row. And that answer is 45.7 2, 2. So later on when we're doing hypothesis testing, we would put the numbers up there for our critical values, but I'm just going to leave it the way it is now. Okay, let's go on. Ooh, that's very tilted. Sorry about that. Let's go on to number 2. Okay, I think it's working now. Okay, sorry about that. Okay, so 2A, asks you to find the sample size. We want to estimate the proportion, and I wrote the word proportion down because when we go to the formula card, we're going to have to pick the formula that has proportion next to it. So we want to estimate the proportion of voters who would again vote for the current president. We want a confidence level of 95%. So that's important. 95% confidence level, that our sample proportion is in error by no more than 3 percentage points. So our error is 3%, which is going to be 0.03. So if it's percentage, you move the decimal point over 2 places. If it doesn't say percent, don't move the decimal point over 2 places. And then it just says, how large should this sample be? Okay, sample size is a 2-step process. On the handout for Chapter 7, I listed those. And I'm going to write the 2 steps. Where? I think I'm going to write them right here. Sample size. Step 1, you deal with the percentage. And then step 2, you use the formula for n. Okay, so I'm going to leave some space. I want to organize this for step 1. And oops, I have an extraneous line. Let me get rid of that. Okay, just thinking how to organize this. So let's do step 1. I'm going to leave room for here, and then I'm going to go to step 2 over here. And again, we're going to go to the formula card, and we're going to get the formula for sample size for a proportion. That's Chapter 7. It's the second box in the second column. Chapter 7 has 2 boxes, one for confidence intervals and one for sample size. And there are actually 2 formulas for the proportion, but I always like to use the second one. So that's the one I'm going to use. And the formula says n is equal to, and then in brackets, z sub alpha over 2, quantity squared, times p hat times q hat, and that whole thing is divided by E squared. Okay, we wanted to look at the formula first so that we would know what table to use to get our critical value. And since it says Z sub alpha over 2, we're going to use that cheat sheet that is located in the bottom right-hand corner of the positive Z table. And that cheat sheet says for 95% that we're going to use a critical value of 1.96. So this is going to be 1.96 squared. Now, they didn't give us any information on p hat or q hat. The only thing we know about p hat and q hat is that they add up to 1, or as I like to call it, they add up to $1. And so if you don't have any information on p hat and q hat, I mean, one could be 20.25, the other could be 0.75. We don't know. But when you don't know, you want to pick the middle of the road. So basically, we're going to assume that p hat is equal to 0.5. And therefore, q hat would also be 0.5. It's basically 50 cents and 50 cents. Okay, I kind of skipped over step 1, left a space there, but let me just show you what you would do in step 1. You would say 95% is equal to 0.95, and then you go to the cheat sheet. Now, in the cheat sheet, they call it the critical value, but in the formula, it's called z sub alpha over 2. But you do get 1.96, and you don't have to show that on the final. You just have to have the right number in the formula. So it's 1.96 squared. P hat is 0.5. Q hat is 0.5. And then you divide the whole thing by the error, which is 0.03 squared. Make sure when you copy the formulas that you copy them correctly and that you don't miss a squared or something like that. Okay, so we multiply that out, and it comes out to be 1,067.111 ... This is the one time on the final exam that you have to round up. Even though it says 0.1, the correct answer here is 1,068. Because it's easy to find 1,067 people to survey, but it's very hard to find 0.1 of a person. So you can't pick a number lower than 1,067.1. So you have to pick 1,068. So there was one time on the midterm when we rounded up, and one time on the final when we round up, and that's for sample size. Okay, now let's do part B. Part B says, on a standard IQ test, the standard deviation is 15. Okay, so we have two symbols for standard deviation. We have the sample symbol and we have the population symbol. You use the sample symbol when n is given, but n isn't given here because we're trying to find n. So this is a population number. So I'm going to put standard deviation sigma is equal to 15. How many random IQ scores must be obtained if we want to find the true population mean? So this one says mean. So we're going to pick a formula that has the word mean next to it. And then it said within 0.5. Hi. I'm making a recording in here, so we're going to have to be a little more quiet. Thank you. What? Right. They had no idea. It's not their fault. They didn't know. His older brother's trying to entertain the kids. They were having fun, but it was just, I don't know if it was being picked up or not, but, oh, I didn't pause. I thought I paused. Okay. Continuing. There's some noise outside that I had to take care of. Okay, so it says population mean within 0.5. So when you see the word within, that is telling you your error. And so the error here is 0.5. And that is not a percentage, so we do not move the decimal point over. And then we want 99% confident in our results. So it's a 99% confidence level. I should have put CL on the first one. I didn't do that, but that's the confidence level. Okay, so again, it's just a two-step process. Step 1, and 2, and the formula that we use is n is equal to, in brackets, the numerator is z sub alpha over 2. I don't really like the way they write that. They've improved it, but it's times sigma, and all over the error quantity squared. So they're completely separate. Okay. So 99% confidence level. Back to step 1, 99% confidence level. And again, we look at the formula and we see that z sub alpha over 2, which tells us we can use that little cheat sheet in the bottom right-hand corner of the positive z table. So 99% is equal to 0.99. And the cheat sheet calls it the critical value. The formula calls it z sub alpha over 2. But the number that we're going to use is 2.575. So when we come down here, it's going to be 2.575 times 15. But when I have a decimal, I don't use a dot for multiplication. So I'm going to put it in parentheses. And that whole thing is over the error, which is 0.5. And then you square the whole thing. So we multiply that stuff out and square, and the answer is 5,967.5625, which would become 5,968. And even if it was, like in the last one, a 0.1, we would still round it up to 68. Okay, that takes care of number 2. Let's go on to number 3. Okay, here we go on to number 3, and number 3 is confidence intervals. And so let's write that down. Number 3, a survey of part A. A survey of 1,000 voters in one state reveals that 408 favor approval of an issue before the legislature. Construct the 95% confidence interval for the true proportion of all voters in the state who favor approval. So, okay, that doesn't look very good, so I'm going to try and erase that. I have to turn the screen so I can see it while I'm working. Otherwise, it's too difficult. Okay, so let me try that again. Oopsies. Hold on, everybody. Okay, sorry about that. Okay, hopefully this will be legible. Number 3, part A. That's better. Okay, so remember for sample size, it was a 2-step process. For confidence intervals, it is a 3-step process. Step 1, use the percentage to find the critical value. Step 2, you calculate the error. And then step 3, you form the confidence interval by doing the plus or minus. Okay, however, in this problem, we're going to have a step 0, as I call it. Because we have to find p hat and q hat. And so, actually, let me write those formulas down right here. P hat is x over n, and yes, you do need to memorize that one. And q hat is 1 minus p hat. Okay. So going back to the beginning of the problem again, it said a survey of 1,000 voters. So N is 1,000. And it said 408 favor approval of an issue before the legislature. So that is your X. X is 408. Don't like that equal sign. It looks a little weird. To make it better or worse? Oh, it doesn't matter. Okay, and we want a 95% confidence interval for the proportion, which I'm just going to call P. So again, when we go to the formula card to pick the formula, we pick a formula with the word proportion near it. So it's the first one in the Chapter 7 box. Okay, so I'm going to copy down. Well, no, first let's find, let's do step 0 and find P hat and Q hat. And then we'll do the 3 steps. Okay, so what I call step 0. I don't even know if that looks like a 0. P hat is equal to x over n, which is 408 over 1,000, which is 0.408. And then Q hat is equal to 1 minus 0.408, which is 0.592. And P hat, like P, always has to be a number between 0 and 1. So you basically have a proper fraction. You have a 408 over the 1,000. Okay, and I'm not quite sure how I'm going to organize this part right here. Here's step 1. I don't want to take a whole other page for this, but I just might do that. Sorry about that. This equipment is very touchy, and it goes out on me quite a bit. So P hat, going back to that, is x over n. And that's not showing up either. So, okay, we're going to try this one more time and see if we can't get this to work. I think so. P hat. Yeah, that looks crappy. But I'm just going to let it go. Is x over n, which is 408 over 1,000, which is 0.408. Okay. And then Q hat is 1 minus 0.408, which is 0.592. Except we didn't get a lot of that, did we? I'm going to try it one more time. Well, I'm just a little frustrated here, folks. Okay, did it erase? Yeah. Q hat is equal to 1 minus 0.408. Now it's working, which is equal to 0.592. Okay. I'm going to do step 1 down here, but I need to write down the formula for step 2 first. So I go to the formula card, Chapter 7, confidence intervals, and the formula, this is for the proportions. P last time I was trying to save room, but now I'll write out the whole thing. And so the formula for the error, step 2, is E is equal to Z sub alpha over 2 square root P hat times Q hat divided by N. Oh, well, that didn't show up very well, did it? What showed up? Just the number 2. All right, here we go one more time. E. Okay, let's pause and fix this because this is ridiculous. Okay, I decided to switch markers to a different color because maybe that one wasn't charged enough. let's see if this one works. E. Nope. Nothing is showing up. Okay, I went back to the black because I think the problem was it wasn't recording right. So we'll try this one more time here. E, yes, is equal to Z sub alpha over 2 square root P hat times Q hat over N. Yes, and everything showed up. That's excellent. Okay, so the reason we have to look at the formula first is to know where we're going to go to get our critical value. And again, the critical value is Z sub alpha over 2. So again, we can use the cheat sheet in the bottom right-hand corner of the positive Z table. So this is 95%, which is 0.95. And I'll do it underneath here. And the critical value, according to the cheat sheet, but again, in the formula, it's Z sub alpha over 2, is 1.96. And everything worked out well there. Okay, so when we come over here for step 2, it's 1.96 square root, and P hat is 0.408 times Q hat, which is 0.592, and that's all divided by N, which is 1,000. And now I'm closing the parentheses. On most calculators, you can't close the parentheses on the inside of a square root because it will only square root that much. So you have to close the parentheses at the very end. And I use a times sign for multiplication instead of a dot or parentheses. Well, a star, really. Okay, so you multiply that out, and we're going to round to 3 decimal places, and it is equal to 0.030. Actually, I'm going to move that over so I have a little bit more room here, and I'm going to put that answer over here, 0.030. Now, to form the confidence interval, I'm going to give you a handout. I do it a little bit differently than the book does. I like to use the formula P is equal to P hat plus or minus the error. So P hat is 0.408. Make sure that you, oops, I don't like that 8. Lots of times students will look up and just grab the wrong number, so make sure that you use P hat. So it's 0.408, very good, plus or minus 0.030. And you have got to have the smaller number first, or you're going to lose a point. So first you're going to say 0.408 minus 0.030. And you don't have to show me this step. I'm just showing you. And then the second one is 0.408 plus 0.030. And when we subtract, we get 0.378. And then when we add, we get 0.438. And again, you don't have to show me that in between step. You just have to have the right numbers there. Okay, let's go on to part B. I have to get a new screen. Okay, now let's do part B of number 3. Number 3, part B. Okay. 35 cars were randomly selected and weighed, and the mean was 3650, and the standard deviation was 420. Construct the, and I'll write this down first, 99% confidence interval for the population mean. So this time we're working with a mean formula. And I'm just going to remind you again that the 3 steps for confidence intervals 1 is the percentage, 2 is the error, and 3 is the plus or minus. There is no step 0 here, but we do have to write down that other information that was given to us, and it was that 35 cars. So that is your N. N is 35. And then it says that they have a mean of 3650. Mean 3650. And because they gave you N, which is called the sample size, that means they're talking about a sample. So you use sample symbols. So the symbol is X. Wow. Holy Toledo. Let me pause this puppy. Okay. Sorry, but this equipment is very, very touchy, and it just stops working. Okay, so what I wrote down over here that I erased is the 3 steps for the confidence interval. Step 1, again, is the percentage. Step 2, you find the error. And step 3, you do the plus or minus. That looks horrible. All right. Okay, that red was not working real well, so I'm going to try green just for the fun of it and see if we can get this to show up. Confidence interval. Oh, it's hard to see. 1 is the percentage. Excuse me. 2 is the error, and 3 is the plus or minus. Oh, that's okay. It's kind of light, but at least you can see it. Okay. We have the sample mean, X bar, and then it also said that the standard deviation, which is still the sample, so the standard deviation is, sample symbol is S, which is 420. Oh, and everything came out. That's nice. Okay, so step 1 will be here, step 2 will be here, and step 3 probably over here. For step 2, we need the formula for the error. So we go to the formula card, to the Chapter 7 box for confidence intervals. And now for the mean, they give you 2 different formulas. One formula if sigma is known, the other formula if sigma is unknown. In anything we ever do in this class, sigma is always unknown. What we have up here is we have the sample standard deviation, S. That's known. But the population standard deviation, sigma, is unknown. So the formula we use is E is equal to T sub alpha over 2 times S divided by the square root of N. My T didn't come out very well. Let's see if I can just go over that again. Yeah, now you can kind of see the T. Okay, so we cannot use the cheat sheet for the Z table because we're going to the T table for this one. And we did one of those in 1B. But to remind you, you start with the 99% is equal to 0.99. Alpha then would be 0.01, how much you need to get to $1. And alpha divided by 2 would be 0.005. But again, remember when using the T table, we need degrees of freedom. And the formula is n minus 1, which is 35 minus 1, which is, I'll put that over here, 34. So that's our degrees of freedom. So now we're going to go to the T table. Oops, sorry about that. Okay, so yes, T sub 0.005, comma 34. And so we go to the T table again, 005 column and 34 row, and we see that the critical value is 2.728. So this is 2.728, and I'm going to use parentheses for multiplication here, not a dot with a decimal. S is 420, and over the square root of 35. And we multiply that out. One more comment. For step 3, I give you this formula in a handout. It's mu is equal to x bar plus or minus the error. And we know from up above that x bar is 3650, which is a whole number. In the previous one, for the proportion, we just rounded to 3 decimal places. For the mean, you round to match the data that you were given. And so since 3650 is a whole number and it doesn't have any decimal places, we're going to round our error to a whole number. Initially, it comes out to be 193.6687, etc. So we're going to round that to 194. And then we bring the 194 over here. And just like last time, I'm not going to show the in-between step, but remember that you have to subtract first. So the lower point is 3456, and the upper point is 3844. Okay. Now we'll go on. Okay, sorry about that. I'm going to do question number 5 now, and then I'm going to do number 4 next time in one whole session. It's all hypothesis testing. So right now I'm jumping to number 5. And in number 5, we're given data, x's and y's. So let me write that down. Number 5. And we have x values and y values. And the x values are 2, 5, 7, 8, and 10. And the y values are 5, 6, 10, 9, and 12. Okay, and on the answers key, I did this problem initially what we would call the long way, but you'll notice on the answers it says, important. The calculations for number 5, parts A and C, can be done completely on your calculator. You do not need to show the work below on the final exam. And a lot of calculators are different, so I'm just going to give the instructions for a TI-8384 kind of calculator. If you have a different type, you're welcome to come see me and I can help you figure it out, or maybe you have the manual. So on the TI calculators, we turn it on, and you're going to push stat, and then you're going to arrow over to calc. So arrow over to calc, and then I just push the number 8. You can scroll down to 8, but it's quicker if you just push the number 8. And 8 on my calculator says lin reg, which stands for linear regression, A plus BX. So that's the version that we're going to use. On some calculators, it's a little bit different. It might be a 9 or something else, but it's lin reg A plus BX. Oh, well, I forgot something. First, you have to put the data in. Oops. So I'll write that underneath here. You hit stat and then enter. And put the x values in L1 and the y's in L2. Okay, so once you've got the data in, the x is in L1, the y is in L2, go back up to what I wrote above there, stat, over to calc, number 8, and then just push enter. This is what your display should look like. It should say linreg, linear regression, and then underneath that it says y equals a plus bx, and then it says a is equal to 2.688. I guess I'll give you the whole thing, 172043, which we're just going to round to 2.688. And b is equal to 0.892 4731183, which we're going to round to 0.892. And some of you might not have this, but I'll explain how to get it in a minute. Underneath that, it says r squared is equal to some number, but we don't really care. And then it says r is equal to 0.944707954, which we're going to round to 0.945. Okay, if you did not get the last two lines on your calculator, you'll look at the number 0 on your calculator, and above 0, it says the word catalog. So you're going to push second, catalog, and then hold the down arrow down. There's a lot of stuff in there. So you hold the down arrow down until you get to diagnostic on, D-I-A-G-N-O-S-T-I-C, on. And you hit enter, and then you hit enter again, and it says done. And then if you go back and do stat over to calc 8 and enter, I didn't put an enter up here, enter, you should get the entire display. And once you've turned your diagnostics on, they are turned on. You do not have to turn them on again. They'll be left on until you turn them off. Okay, so hopefully you all have that, and now we'll go on. Okay, so this is all you need to show me on the final exam. So for number 5, and again, I showed the long way on the paper in case there are some students who have a calculator that won't do linear regression, but for most of you, you're just going to say number 5, part A, I ask you to find the linear correlation coefficient R, and all you have to write down is R is equal to 0.945. That's all the work you have to show, and that's 5 points. Okay, part B says, is there a linear correlation between the x and y values? And you have, then I say do a test, because you have to do a hypothesis test. This is the last one here. And in order to do that, this is for part B, you're going to use table A-6, which is right next to chapter 13 on your formula card. So get your formula card, find chapter 13, and then right next to it, you will see table A6. Hypothesis tests are 5 steps, and you will get a handout with the 5 steps on it for the final. Step 1, you need to come up with your null hypothesis and your alternative hypothesis. And if you look at table A6, right at the bottom of the table, they actually tell you what HO and H1 are. So HO is that rho is equal to 0, and H1 is that rho is not equal to 0. And I'm going to draw a picture of this one. I'm probably the last one I put. Okay, so the picture looks like this. It's not curvy like the other ones we've always worked with. And R is a number that can go from anywhere between -1 and +1. So we put +1 over here and -1 over there. And it is going to be a two-tailed test. And so we're going to have to find the critical values. Hopefully this red one's going to work for me. I don't know how to fit this. Okay, this section and this section are reject HO, and that is reject HO. The middle section I'm going to abbreviate, and that one is FTR, fail to reject. Oh, that doesn't look very good. Let's see if I can get that a little bit more legible. Okay, let's see. It's FTR, which stands for fail to reject HO. But, oh, and I haven't gotten any extraneous lines. That's good. I'm going to draw a line here. R measures the strength of the linear relationship between the two variables. And R, if R is near +1, you have positive correlation. If R is near -1, you have negative correlation. And if R is near 0, then you have no correlation. I think they might. There's a picture on page 503 of this. Of course, doesn't look quite like mine. But we're trying to answer the question here whether there is correlation or whether there is not correlation. And so we came up with an abbreviation. We do C, and then in the middle no, and then C. So if your test statistic falls where the C is on the two outside regions, then there is correlation. But if it falls in the middle where you fail to reject HO, then there is no correlation. Okay, so we have our step 1. Step 2, alpha is not given to you. And when alpha is not given to you, you assume that alpha is equal to 0.05. Oh, I'm getting extraneous lines here. Let me pause for a second and see if I can't. Oh, my goodness. Okay, I got rid of most of the lines. There's still that one line on the one side, but we're just going to live with that. Okay, normally, on a two-tailed test, you would divide alpha by 2, but this time you don't. And even if you did, you're going to go to the table, and there is no 0.025, and then hopefully you're going to remember that you don't have to divide alpha by 2. The reason that you don't divide by 2, because in all the other ones we do, is that the footnote at the bottom of the table tells you that this table can only be used for a two-tailed test. So they built the divided by 2 into the table for you to make it easier. Okay, step 3. You'll notice that the first column of the table is not degrees of freedom, it's n. And n is the number of points. In other words, we were supposed to start out by graphing these, which I didn't. But we have 5x values and 5y values, so we have 5 points. Yes, we got 10 numbers, but n is the number of points. And so we have, so n is 5. N is equal to 5. And then we use r here. So we want r sub 0.05, comma 5. And when you go to the table 055, the value is 0.878. But there's 2 of them, so it's a plus or minus. So this is a positive 0.878, and the other one is a negative 0.878. Should have made the picture a little bit bigger, huh? Okay, I like to write a sentence that says reject HO if R is less than the negative number 0.878, or if R is greater than the positive number 0.878. And no, you do not combine those into one inequality. They have to be 2 separate ones. Okay, but here comes the good news. For step 4, your test statistic is R. So all you do is look back up at part A, and you see that for R you got 0.945. So you don't have to do another calculation. But you do have to rewrite it in step 4 to show me that that's what you're using. If you leave that out, you're going to lose a point. Okay, so we got 945, which is larger than 0.878. So we reject HO, and so step 5, there's 2 parts. Initial conclusion is reject HO. And the final conclusion, normally we talk about a claim, but in this one we don't. We just answer the question whether there is correlation or not. And yes, in this case, there is correlation. Okay, and I'm going to tell you that that's the same answer that you're going to get on the final, because if there is no correlation, then you can't go on and do part C. And part C is to come up with the regression line. It's the line that fits those points. Okay, and so remember from the display from the calculator that you have y equals a plus bx, and a turned out to be 2.688, and b turned out to be 0.892, and don't forget to put the x, because that is very important. So that is the regression line. Now, once you've done that, in the next step, which is a separate step, I ask you to predict y when x is 10. So then you're going to substitute 10 into the equation for x. And that turns out to be 11.608. But again, please remember to give me the equation with the x in it first, and then plug in the value of 10. Okay, so I'm going to do part D now. This is 5D. And we're talking about rank correlation. And the symbol is R sub S. The R we were talking about earlier is the original R. And this is another R sub S for Mr. Spearman. Okay, I learned this one horizontal, and that's the only way I can do it. So let's see, where should we do this? We've got a lot of room here. So I think I'll do it right here. And you're going to need 6 rows. And X, Y, and what? 6 columns too, I think. 6 rows and 6 columns. And I need one more. Okay, the X values are 2, 5, 7, 8, and 10. And the Y values are 5, 6, 10, 9, and 12. Okay, so that's how we start. Okay, and now I'm going to I'll try the green. So we are going to rank the x's. Rank sub x. Let's make this line a little longer. put another line here. And then we're going to have this one. And I think that's all that I need. Okay, so we're going to take a look at the x numbers. And we rank from lowest to highest. And the lowest number among the x's is the number 2. So that gets a ranking of 1. The next number, next lowest number is number 5. So that gets a ranking of 2. 7 is 3. 8 is 4. And 10 is 5. So the x numbers were in order, 1 through 5. Now let's take a look at the y's. So we're going to rank sub y. Okay, the lowest y is 5, so that gets a ranking of 1. And then 6 is second, but 9 is third, 10 is fourth, and 12 is fifth. So that's what your rankings look like. Now, we're going to find D. And D stands for difference. That's a little better. And now we're not talking about the original numbers. Ignore those. We're just talking about the rankings. And difference means subtract. So 1 minus 1 would be 0. 2 minus 2 would be 0. 3 minus 4 would be negative 1. 4 minus 3 is positive 1. And 5 minus 5 is 0. One more line here. The last line is D squared. So you take each of the differences and square them. So you get a 0, another 0. Negative 1 squared is positive 1. I get a lot of students who put negative 1 here, but if you put it in your calculator, put parentheses around the negative 1 and then square it. Or just remember that a negative times a negative is a positive. So we get a 1 here, a 1 here, and then a 0. And the only thing that we need from this entire chart is the sum of the d squareds. And in our case, the d squareds added up to 2. The formula that we use here is in Chapter 13, right next to the table that we used for Part B of number 5. It's the second from the bottom, and it's called rank correlation. And the formula is R sub s is equal to 1 minus 6 times the sum of the d squareds over n, and then in parentheses, n squared minus 1. Okay, be careful when you copy the formula that you copy it correctly. Frequently, students will put the 1 in the numerator and then put the denominator over the whole thing, but that's not right. The 1 is all by itself. It's just the number 1 minus 6 times the sum of the d squareds, and the sum of the d squareds is 2. And n, remember, was 5, because we have 5 points. So it's 5 parentheses 5 squared minus 1. So that's 1 minus, you get a 12 in the numerator, and you get 120 in the denominator. And you can just put it in your calculator like that. I know that reduces, and I reduced it on the answer key, but you don't have to. You can just say 1 minus 12 divided by 120 in one step, and it comes out to be exactly 0.9. So that is the value of R. We are supposed to go do a hypothesis test with another table at this point, but I'm hypothesis tested out, so all we do here is just find the value of the linear correlation coefficient, or the rank correlation coefficient. I'm going to stop now, and I will record number 4 on Tuesday afternoon after my afternoon class, and then I'll post that. So hope you had a nice Thanksgiving, and I'll be sending out the sign up for the final pretty soon here. Okay.